So here is the example for section 12.2. The first one is going to be, they ask you find the derivative of, I'm gonna write down r prime of t. Then they ask you to find r of t naught and r prime of t naught, but they're telling you t naught equal 1. So r of t, here is the function which is equal 3 plus t, 3 plus t, this is for the I, and plus t cubed for the j, plus t cubed for the j. So if you work on this one, it's going to be fine. My way to work with this example, I'm always converting to the vector form, so it's going to be like this. Now, this is r of t, which is the same thing. The derivative of this one is going to be the derivative of the first part, which is going to be 1, because the derivative of the 3 is going to be 0, derivative of t is going to be 1. The derivative of t cubed is going to be 3t squared. We're done from this one. Now they ask you to find r of t naught, which is equal r of t naught is 1. That means I'm going to plug in 1 in r of t. So it's going to be 3 plus 1, and it's going to be 1 cubed. That means it's going to be 4 and 1. This is the first one. R prime to the t naught is going to be r to the 1, r prime to the 1. And it's going to be, now I'm going to plug in 1 in the derivative. So the first component 1, and the second one is a 3. So I need you now, we're done. That's what they ask you. Now we have to learn how to graph it. So keep in your mind, this is the prime for t naught, and this is r for t naught. So let's graph these. That's what they ask you. The first thing I'm going to type here, here is the vector. Let's check the first one. It's going to be r prime of t naught, which is 1, comma 3t squared. 3t squared. That's it. And r of t naught is going to be r of t naught 141. There is 4, comma 1. And here is going to be 1, 3. The next part, we have to check how we're going to graph it. The first thing, we're going to graph the function, which is r of t naught. Let's graph the function r of t naught, which is 4, 1. Because we need to choose which one is the right one. So I'm going to choose, here is r, but 4, 1. 4, 1, not 1, 4. So this is 1, 4. We need to grab the vector. So 4, this is 4, and this is 1. So you see this vector, r of t, it's 4, 1. So here is the vector 4, 1. I'm talking about the vector, not the point. The vector is 4, and here is 1. Now, this is r of t. To graph the prime, we're going to start from this point. From this point and check how much 1, 3. That means you're going to go to the right 1 unit and the 3 up. So let's check this one. 1 to the right, that means it's going to be 5, and the 3 up. 1, 2. 1, 2. So I start from this one. That's means we're gonna go 1 and 1, 2, 3. It's keep going up. But check this one is the right one. If you look to this one, the vector r of t is -2, 1. This is wrong. The vector r of t, this one is 1, 4. So this is wrong because we're gonna depend about r of t. R of t which is 4, 1. So this is not 4, 1. This is 1, negative 2. This is 4, 1. And then the derivative is going to be started from this one as an origin point. Then you're going to go 1 to the right and 3 up. And that's why it's keep going up. So this is the right choice. So you're going to graph the R of LT first. Then you're going to start R of LT as an origin point and keep going up. This is an origin point. Then I'm going to say how much the prime. R prime is 1, 3. So I started from this point, 1 and 3 up. So this is the right option. The same thing now with this one is going to be different functions. So that's why you have to be careful. So the second one, we have the same thing, R of LT equal. Now they give you already in the component form. So e to the t and e to the 2t. So now we need to find the prime. That means R prime of LT is going to be, the derivative for ET is going to be ET. And the derivative for 2ET is going to be 2 and the same function, exponential function, because you have the derivative of the exponents. Now this is R. They ask you T naught equal 0. That means R to the T naught is going to be R to the 0 and equal R to the 0, E to the 0, and E 2 times 0. So it's going to be 1. And also here is going to be 1. Then R prime to the T naught is going to be R prime to the 0, which is equal. I'm going to plug in here now. So it's going to be E to the 0 and 2E to the 2 times 0. That means it's going to be 1 and 2. So that's it for the second example. Now we need to graph it. First of all, we have to graph the vector value function. Then we're going to graph the prime. So let's type these. R prime is going to be E to the T. I think I can use this one. E to the T. I forgot to put this one. And E to the 2E to T. 2, here's the E. And 2T. And then this one is going to be in the vector forms. R of a T naught is going to be 1, 1. And the second one with the vectors is going to be 1, 2. 1, 2. So here's the option now. To graph it, we're going to graph first of all the vector value function. Then we're going to graph the derivative. So 1, 1. Check where's the graph. We'll start with 1, 1. So this point, no, I need to see the R. R, this is 1, 0. R, this is 0, 1. This is wrong. This one is 1, 1, and this one is also 1, 1. So maybe these two options. Now we need to start from this point and grab the derivative, which is 1, 2. So I'm going to say 1 and 2 up. That means this is going to be wrong because here's 1 and 2 up is going to be here. That means the graph is going to be here like this one. So here is the R of LT. Then I'm going to say 1 and start again from this point, 1, 2. So here is the derivative of this graph. I'm gonna choose this one. So you're just gonna find the derivative for each component, 6t to the power 5, and the second one is -7. The same thing with this one, but now we have different type. We have sine and cosine. So find the derivative of those. This is 4. I think, yeah, this one is going to be changed with number. So r of t equal 2 cosine. They already give you on vector component form. 2 cosine t and 3 sine t. So you're just gonna find the derivative for each component. So to the cosine, the derivative is sine. So here's 2, and this is negative sine to the t. And here's 3, the derivative of sine is cosine. That means it's going to be -2 sine t and 3 cosine t. That's it. This is for the third one. So we're just gonna type. There we go. It's going to be -2 sine to the t. We have to close the parentheses, comma, 3 cosine to the t, and close the parentheses. That's it for this one. Now with the next example, 5, it's just a 3. That means we're working with the space I, J, K. So we're gonna do exactly the same steps. Example 5. So it's going to be R of t equal. Let me look. Yeah, e to the -t I plus 4j plus 2t e to the power tk. If you want to work on this one, it's going to be right. Don't confuse yourself about I, j, k. Or you want to convert it to the component form. It's going to be e to the -t and 4 and 2t e to the t. Here's the thing. Now we need to find the derivative for this one. You see, that's why always trying to convert it to the component form. So you're gonna work on each one separate. So the derivative of t is going to be, for the first one, it's exponential function. So the derivative is going to be for the exponent, which is negative, is going to be e negative t. Because the derivative of the exponent is going to be in the front and exactly the same function. The derivative of constant 0. Here is the important part now with this example. Because now with this example, we have 2 functions. This is the first one, and here is the second one. So to find the derivative, so I'm going to say the first one times the derivative of the second one. So here is the first one times the derivative of the second one is going to be e over t plus the second one times the derivative of the first one, which is 2t. So the derivative is 2. So now you see this is the h component. So that means the derivative is going to be negative e to the negative t and 0. And just simplify this one. Not simplify, just rewrite down this again. Plus 2e to the t. You can write down this as a negative e to the negative t, 0. And I'm going to say e to as a common. So it's going to be 2t plus 2. So you can write down this, you can write down exactly the same thing. So both is going to be right. So let's type this one, example 5. So another trick. So it's going to be negative e to the exponent negative t and comma 0 comma. Let's write down e to the t then parentheses 2t plus 2. That's it. Let's check this one. Example 6. This one is exactly the same thing. R of t is the inverse. It's a vector component. So r to the sine, which is sine inverse to the t, and r to the cosine is going to be cosine inverse to the t. So now with this one, you have to go back to Cal2 and check how we're going to find the inverse for this one. So let's write down here these two rules. If you remember, sine inverse to the u is going to be u prime over square root of 1 minus u squared. This is for the sine inverse. Cosine inverse to the u is going to be negative u prime over 1 minus u squared. So these two rules, we can use it for the sine and cosine. So now to find the derivative for this one is going to be the derivative for the first one. And instead of u is going to be t. So it's going to be t prime, which is mean 1. Because the derivative of t is 1. Then over 1 minus t squared. And the cosine is going to be negative 1 over square root of 1 minus t squared. That's it. So keep these two rules in your mind. The third component, we have 0 here. So the same thing. It's just the 0 is going to stay 0. Comma 0. So we're going to type this one here in the vector form. So it's going to be 1 over, I think with the operation, yes, 1 over square root of 1 minus t squared and comma. The second one is negative 1 over square root of 1 minus t squared and comma 0. Not here. Come on. Comma 0. That's it for this example. Before I work on this example, let's convert it to this one, to the component form. So I'm going to say t squared plus 60 and t squared minus 60. Then r prime to the t is going to be equal 2t plus 6, and here is going to be 2t minus 6. Then r double prime of t is going to be 2 and 2. So this is r prime, this is r double prime. So now we need to find r prime dot product with r double prime. So it's going to be, it's dot product, be careful. 2t plus 6 and 2t minus 6 dot product with 2 and 2. So now this one is going to be this one times this one plus this one times this one. Because it's dot product. So it's going to be 2t plus 6. I put parentheses times 2 plus 2t minus 6 parentheses times 2. And this one is going to be 4t plus 12 plus 4t minus 12. And the result is going to be 8t, because this one cancel with this one. So that's it for this example. So we're just going to type here, the dot product is 80, and here is going to be 2t plus 6, 2t plus 6, and comma 2t minus 6. And then the second one, the double prime, is going to be just 2 comma 2. And this one is going to be, the dot product is 80. That's it for this example. This is my way to solve this example. I feel like it's easier to work with the component form. If you want to keep the ijk, it's fine. So r of t is going to be 2t squared and negative 5t and 5 over 6 t cubed. 5 over 6 t cubed, yeah, that's right. Now the first thing, we need to find the prime. So r prime of t is going to be, it's going to be 4t, and it's going to be negative 5. And the third one, be careful when you're taking the prime for this one, because it's going to be this one times 3. That's mean 15 over 6. 15 over 6, which is equal 5 over 2. So this one is going to be 5 over 2 t squared. So this is r of t, this is the prime. They ask you to find double prime. That's mean r double prime of t is going to be, this one is going to be 4, this one 0, and this one is going to be 10 over 2, which is 5. So 5t. Because 5 over 2 times 2 is going to be 10 over 2, which is 5. And here's t. So here is the prime, here's double prime. They ask you now to find the dot product between the prime and double prime. So r prime times r double prime r prime of t times r double prime of t is going to be this one dot product with this one. So 4t negative 5 and 5 over 2 t squared, and everything is dot product with 4, 0, and 5t. That means it's going to be 16t plus negative 5 times 0, so plus 0. 5 over 2 times 5 is going to be 25 over 2, so plus 25 over 2 t cubed. So the result is going to be 16t plus 25 over 2 t cubed. That's it for this one. Now the next part is to find the cross product. So the cross product now between R prime of T cross product with R double prime of T. So if you remember the cross product, so this is for the I, for the J always minus, and here is the K. Always I'm gonna write down R prime here. The second one is going to be here. So R prime is going to be 4T and negative 5 and 5 over 2T squared. And the double prime is going to be 4, 0, and 5T. Now let's find the cross product. Now for the I, is going to be negative 25 minus 0. So for the I, for the first component, is going to be negative 25T squared, T, negative 25T. Because minus this one is 0. For the second component, the J, there is minus here. We're going to put parentheses, then I'm going to distribute. So it's going to be 20T squared. And this one times this one is going to be, cancel the 4 with the 2 is going to be 2, is going to be 10T squared. So minus 10T squared. For the second component. For the third one, 0 minus 20. Minus negative 20, so it's going to be 20. Negative 20. So this one is going to be negative 25T. And this one is going to be, you can combine these together, it's going to be 10T squared. And there is minus, so negative 10T squared. And the last one is going to be 20. That's it for this example. So we're going to type here R prime, which is going to be 40 and comma negative 5 comma 5 over 2T squared. 5 over 2 and T squared. For the double prime is going to be 4, 0, 4, comma 0, comma 5T. The dot product is going to be, here's the dot product, 16T, 16T. You don't have to put it in bracket because it's going to be a number. Always the dot product between two vectors is going to be a scalar. So you don't have to write down. So it's going to be 16T, careful with this one, plus 25 over 2T cubed. The cross product, you can write down as a vector, you can write down as not a vector, so it's going to be negative 25T, comma, negative 10T squared, and comma 20. That's it for this example. So let's check how we're going to work on this example. The first thing, I'm going to convert this one to the component form. Because again, I told you it's easier to work with the component form. So this is 4T and this is T squared. And here is the U. The U, this is 5T and this is T squared. And here is T cubed. So this is I, R of t, this is U of t. Now the first thing they ask you, find the R prime. So this is A. So R prime of t is going to be 1, 4, and 2t. The second one, they ask you to find the derivative with respect to the t, 2 times R of t minus U of t. So B, they ask you to find d over dt 2 R of t minus U of t. So the first thing, find this one here. That means this one is exactly the same thing. I need to find the derivative for 2 times R of t. So it's going to be 2 times t is going to be 2t. And here is going to be 8t. And here is going to be 2t squared. Minus U of t, which is 5t, t squared, and t cubed. Then I'm gonna combine these together. So it's going to be 2t minus 5 is negative 3t. 8 minus t squared. So you can't combine these together. So it's going to be 8t minus t squared. And the third component is going to be 2t squared minus t cubed. Now here is everything inside. Now we're going to find the derivative for this one. So the derivative is going to be, this one is going to be equal negative 3. And here is going to be 8 minus 2t. And here is going to be 4t minus 3t squared. That's it for this one. So you see with the third one, find the derivative between two fractions. So that's why I'm telling you, be careful on this one. So this is a vector with the scalar. Let's check that. C, find the derivative d over dt for 3t u over t. These are two functions. This is vector value function, and this is another function, 3t. So how are we gonna find sorry, it's 5t. So we're gonna do, we're gonna say this one equal the first one times the derivative of the second one, which is the u prime of t, plus the second one times the derivative of the first one, which is 5. Then I'm gonna say here's 5t, and here is, it's look like a scalar now, and here is u prime. We need to find the u prime. So here is u prime equal 5, 2t, and 3t squared. That means u prime is 5, 2t, and 3t squared, plus u over t, which is 5t, t squared, and t cubed times 5. This one is going to be 25t, and here is going to be 10t squared, and the third one is going to be 15t cubed, plus this one is going to be 5t sorry, 25t, and it's going to be 5t squared. And the third one is going to be 5t cubed. So now we're just going to add these together. So it's going to be 50t, and 10 we can add with this one. Is going to be 15t squared, and it's going to be 20t cubed. So if you notice that, because this is not a vector value function, if you said 5t times u, 5t times u, so 5t times 5t is going to be, here is the u, yeah, it's going to be different because we're multiplying by the u prime. 5t is going to be 25t squared, and this one is going to be 5t cubed, and this one is going to be 5t to the power 4. So that's the difference. So this is for C. If you look to the D and E, it's dot product and a cross product. We can do E here, because it's the dot product between R of T and U of T, and then we have to find the derivative. That's mean you're going to use the rule. It's going to be the d over dt to the u of t r of t times u of t. Is going to be the first one times u prime plus the second one times the derivative of the first one. So here is r prime and here is u prime. So we're going to use these two. That means this one is going to be r of t, which is t 4t and t squared, dot with u prime, which is 5 2t and squared, a plus. Now we have u, which is this one, 5t t squared and t cubed times the derivative of r, which is 1, 4, and 2t. So let's do the dot product here. So it's going to be t, that's mean 5t plus 4t with 2t is going to be 6t, and t squared with the t squared, so plus 4t squared. This dot product, so it's going to be 3. We're not adding. Wait a minute. So this one's going to be 8. So 1 times 5, 5. This one is 8. And this one is going to be 3t squared. Plus the second one. This is not a vector. That's why I confuse myself. It's a dot product. So the result is going to be scalar. Plus, we're going to add the second part, which is 5t plus 4t squared and plus 2t to the power 4. Now we're just going to add these together. So it's going to be 5t. 5t is going to be 10t. And there's something wrong here. Multiplying this one times this one, this is squared. Multiplying this one with this one, this is for the power 4. So 10t plus 12t squared plus 5t to the power 4. 12 and here's 10. Yeah, that's it. This is the dot product for the E. I'm gonna do this one on the second page because I need this information here. So D is going to be find the cross product between R of t and U of t. So D over dt to the R of t cross product with U of t. So the same thing, this one is going to be the first fraction cross with the derivative of the second one plus the second one cross with the derivative of the first one. So now we have R of t, which is t 4t and t squared cross with the prime of u, which is 5, two t and 3t squared. This is the first part, plus u of t, which is 5t t squared and t cubed. This one across with r prime, which is 1, 4, and 2t. So we have to find the cross product here and the cross product on the other side. This one is going to be, I can do it here. This is I, J, and K, and here is minus. Always minus with the J. So the first one is going to be, I'm going to put R of t, which is t, 4t, and t squared. And I'm going to put the prime of t here, 5, and 2t, 3t squared. Now this one plus the second part, I'm going to do the cross product here. This is I, J, K. And always this is minus. The first one is 5t and t squared and t cubed. Here's 1, 4, and 2t. Now let's do the cross product on the first part. For the I, is going to be, let's read this one, the component 4. It's going to be 12t cubed minus 2t cubed. For the j, here's the minus, is going to be 3t cubed minus 5t squared. For the k, is going to be 2t squared minus 20t. I'm done from the first part. Here is the plus. For the second part, going to be here. The same thing for the I is going to be 2t cubed minus 4t cubed. For the j, here is the minus, is going to be 10t squared minus t cubed. For the k, is going to be 20t minus t squared. Now we're just going to add these together and compound the like terms. So this one is going to be, This is already like term, so 12 minus 2 is going to be 10, and here is minus 2. That means it's going to be 10 minus 2 is going to be 8. So here is going to be, for the first one, is going to be 8t cubed, because all cubed on the first part. The second one is going to be, this is negative 3t cubed plus 5t squared. And this one is negative 10t squared plus t cubed. So we're going to add these together. So negative 3 with the 3. So negative 3 plus 1 is going to be negative 2t cubed. And this is squared with the squared. So it's going to be minus 5t squared. Minus 5t squared, yes. And the last one, this is t with the 20. So 20 with the 20 is going to go on 0. And 2t squared minus t squared is going to be just t squared. So that's it for the cross product. The derivative of R3t. So this is the last one, F. Find d over dt to the 3, no, to the R3 over t. So don't confuse yourself. It just means you're going to plug in instead of each t, 3t. So it's going to be the derivative of, so R of t, let's go down a little bit. This is R of t. I'm going to plug in a 3t here, 3t here, and 3t instead of t squared. So that's the difference on this one. So it's going to be, here is a 3t, and the second one is going to be 12t, and the third one is going to be, because it's 3t squared, that means going to be 9t squared. 3t times the 3t is going to be 9t squared. Find the derivative for this one. It's going to be, this is as a vector. So it's going to be 3, 12. I'm looking to the R. 4, yeah. 12, yes. So this is 12, and this is going to be 18t. That's it for this problem. So let's go to example 10, 10, 11, 12. 12 is a little bit, we have to remember some rules, and I can solve these two. Let's see, yes, these two for you. But the third one is going to be, you're going to get exactly the same thing. So I'm just going to solve a little bit from example 12, just this part. So let's do example 10, how to find the derivative, sorry, the integral. So the integral for example 10 is 2ti plus j plus 9k dt. Is the integral of 2ti plus j plus 9k dt. So this one is going to be exactly the same thing. If you convert it to the component form, it's going to be the integral of 2t and the integral of 1, because the j, and the integral of 9 dt. So it's going to be the integral for each part. So what I'm going to do here is be careful here. That's really important even when you're plugging on WebAssgin. Because you remember every time when you take an integral, we're going to add a constant c. So I'm going to take, this one is like taking the integral for 2t dt. You don't have to do these steps. We're just going to have to understand. And the integral of the dt and the integral of 9 dt. So if you're taking the integral for this one, is going to be 2t squared over 2 plus c1. If you're taking the integral for this one, is going to be just t plus c2. If you're taking the integral for this one, is going to be 9t plus c3. Because every time when you take an integral, we have to add the constant c. Now here with this one, we're going to write down this, the vector 2. This one is going to be t squared plus c1, and this is t plus c2, and this is 9t plus c3. So we're going to write down as a t squared, t and 9t plus c1, c2, and c3. So the result is going to be t squared, t, 9t plus, we're going to write down a bold c. That's what you're going to do on webassgin as a vector. So this is a vector c with the constant, and here is the integral for this function. So this is really important because I think here they ask you to type it like this. Let's check that for this example. So it's going to be, I'm going to write down in the vector form. I'm going to say t squared comma t comma 9t. This is the vector, and this one is supposed to be plus and c. We're going to type the bold c. Let's go to the vector. Here's bold. Yes, this one. Let's check this one. That means this is a vector c. Let's do the same thing with this one. It's going to be exactly the same like example 10. You have to do the integral for each part. So 10 is going to be, 11. It's going to be the integral of 4t cubed. 4t cubed for the I plus 6tj plus, no, minus 7 square root of tk. Of tk. Everything to the t. So this one is going to be the integral of 4t cubed and 6t and the integral of negative 7 square root of t. You can convert the square root of t away as a t to the power half. And with respect to the t. So this one is going to be the integral for the first one. And you don't have to do these steps. Just go ahead and do the integral for each part. So for this part is going to be 4. You're going to add exponents here to the power 4 over 4. And for the second part is going to be 2t squared over 2. And for the third part is going to be 7 over 2, because this one is going to be add 1, 3 over 2. So 7 over 3 over 2, t 3 over 2. It's -7. That means this one is going to be t to the power 4, and it's going to be 3t squared, and this one is going to be -14 over 2 over 3. -14 over 3 t to the power 3 over 2, and plus the vector c. So let's check this one. As a vector, we're going to type t to the power 4 to power 4, comma, and the second one is going to be 3t squared, so 3t squared, and the third one is going to be -14 over 3, -14 over 3, and here is going to be t to the power, and the fraction on the power. Can I do that? Yes, 3 over 2. Oh, I forgot the c. Add to the vector the bold c. So the bold c, if you type c, is going to be wrong. So example 12, so you can remember, it's the integral of e negative t sine t for the I plus cotangent t for the j, and everything dt. I'm going to convert this one to the component form, e to the negative t sine to the t, and the second one is going to be cotangent t dt. I'm going to find the integral for this part. And you have to do this one because you're going to get exactly the same example. And you're just going to add these together as a result. So how to find the integral of e to the t sine t dt? I'm just going to find this one. So we have to use the integral by parts, which is the integral by parts uv. This side is going to be the integral of u dv is going to be u times v minus the integral of v du. Integrals by parts. So we're going to use this rule. So I'm going to let this one u and this one the dv. So u equal e to the negative t. That means du is going to be equal negative e to the negative t dt. And I'm going to let the dv equal sine t dt. Sine t dt. That means the v is going to be negative cosine t. I'm going to plug in everything here. So the integral of e to the t sine t dt is going to be equal u times v. Here is the u and here is the v. So it's going to be negative e to the negative t cosine t and minus the integral of v. Here is the v, which is negative cosine t dt, negative cosine du, which is also negative, times negative e to the negative t dt. That means this one is going to be equal negative e, negative t, cosine t minus negative times negative positive. So it's going to be the integral of cosine t. Let's flip these to write down exactly the same thing. So it's going to be e to the negative t cosine t dt. Now I didn't finish because on this part here is the same thing, which is by parts. We're gonna integral by parts. So I'm gonna say the same thing here for this part. Is going to be the u equal e to the negative t, and dv now is cosine t dt. So du is going to negative e, negative t, and v is going to be sine t. I'm gonna do the integral by parts on this one. So the integral of e to the t, so to the negative t, sine t dt is going to be this one equal negative e to the negative t cosine t minus, I'm going to do the integral by parts here. So this one is going to be uv, that's mean e to the negative t, and v, which is sine t minus the integral of v sine t du, which is e to the negative t dt. This is here as dt. So now we're just gonna arrange, we're not gonna keep going. You're gonna stop on this point. I'm gonna show you why. So the integral of e to the negative t sine t dt is going to be negative e to the negative t cosine t minus e to the negative t sine t plus, we have, this is minus, this is minus, because here is negative sine, negative is going to be positive. Are we missing sign? Du with the negative sign, yes. We're missing the sign. So this is yes. So we're missing negative sign here with the u, which is negative e negative t dt. That means negative here is going to be plus. This one is going to be negative, negative, positive, and negative is going to be minus the integral of sine. I'm gonna write down e to the negative t sine t dt. Now, if you look to this one, this side of this part is exactly the same thing. So I'm going to move this one to the other side and add it together. So this one is going to be 2 the integral of e to the negative t sine t dt, because you're going to move this one is going to be plus, and you're going to add these together is going to be 2 the integral and equal negative e negative t cosine t minus e negative t sine t. Then the integral for this one, divide both sides by 2. So it's going to be e to the negative t sine t dt equal half negative e negative t. You can take the negative, this one as a common. So it's going to be negative half e to the negative t as a common. And here is going to be cosine t plus sine t. That's it. This is just the integral for this side. How are we going to find the integral for the cotangent? You have to look for that. But you're not going to use integral by parts, only the integral by parts for this one. I'm not going to solve the second side because you're going to get exactly the same example. We're going to go back to calculus 2. So what we did here, we find the integral for the length for this vector, which is the square root of t squared plus t to the power 4. Then I'm going to take t squared as a common, and the square root of t squared is going to be t, and here's the left. On this part, how are we going to find the integral? We're going to find the integral by substitution. So I'm going to say let u equal 1 plus t squared. Let u equal 1 plus t squared. That means du is going to be 2t dt, because we're going to find the derivative with respect to the t. That means if I divide this one by 2, cancel here. So du over 2 is going to be equal t dt, which is equal t dt. That means the integral now is going to be from 0 to 2. T dt is going to be du over 2. Square root is going to be square root of 1 plus t squared is u. So now it's easier to find the integral. I'm going to take half outside. So this one is going to be half the integral from 0 to 2 is going to be u to the power half du. That means this one is going to be half. This one is going to be u 3 over 2 divided by 3 over 2 from 0 to 2. There's no c. You're not gonna add the c because there's a boundary for this one. So here is going to be, you're gonna flip this denominator here. So it's going to be 1 over 3 u to the power 3 over 2 from 0 to 2. And this one is going to be, now we're done. We did the integral. We have to bring back u equal 1 plus t squared. So this one is going to be 1/3 1 plus t squared from 0 to 2. Now we're done. We're just going to plug in. So this one is going to be plug in the 2. So it's going to be 1 plus 2 squared 4 plus 1. So it's going to be 5 over 3. Let's keep 1 over 3 here. So it's going to be 5, because 2 squared 4 plus 1 is going to be 5, minus, plug in the 0. So it's going to be plus minus 1. That means it's going to be 0. 1 plus 0 is going to be 1. So it's going to be 4 over 3. We forgot the exponents. We forgot the exponents. It's 3 over 2 from 0 to 2. That's really important. It's make everything different. So let's check that. So here we're gonna plug in 2 here. So it's going to be 1 plus 4 is going to be 5 to the power 3 over 2. 3 divided by 2. It's going to be it's a really big number. 5 to the 3 over 2. We don't need to find as a decimal. I don't think so. This calculator is going to work because I can't convert it. So what I did, I just simplify it because this one is going to be a decimal number. I don't want to write down decimal number. If you plug in, this is 3 over 2. This is going to be 4 plus 1, 5. So it's going to be 5 here to the power 3 over 2. Just going to convert this one. It's going to be the square root of 5 cubed. And if you plug in the 0 here, it's going to be 1. Oh, the 0 here is going to be different. 0. It's going to be 1 to the 3 over 2, which is 1. So just keep it like this. Next example, find r of t to this function, which is, but there is something different with this one. We have r of 0 equal to I. Find r of t. We have the prime, and we need to find r of t. Let's check what's the difference with this one. Example 14. So example 14, if you look here, that's mean we're going to find the integral. So we have r prime of t equal 4e to t. I'm going to write down as a component form. So 4e to the power 2t. And the second one is 5et. So this is the prime. That means we need to find the r of t. R of t, that means it's going to be the integral for 4e to the 2t and 5e to the t with respect to the t. So I'm going to find the integral for this one. 4 is going to go out. We're going to add 1 here. This is the same function. So it's going to be 4 over 2. And this one is going to be 4 over 2 e to the 2t. This is the first component. And this one is going to be, you're going to take the 5 out. So still the same thing. 5. The integral for the second one is going to be 5 e to the t. So now this is 4 over 2. So it's going to be 2 e to the 2t. And here is 5 e to the t. Now, what's the next step? What are we going to do? This is r of t. R of t plus c, the vector c. Because we're going to add c1 here, c2 here, and here is the vector of c. Now we need to find how much is going to be this vector. They're telling you r of 0 equal to I. They're telling you r of 0 equal to I. That means if you plug in r of 0 here, plug in 0 here, is going to be, I'm going to plug in r of 0 is going to be 2e 2 times 0 and 5e to the 0 plus the vector c, which is c1, c2. It's a vector. R of t is 2i. This is mean it's a vector. I is 2 and j is 0. That means this is 2 and 0 equal 2. This is 1 and this is 1. So it's going to be 5 plus the vector c. That means the vector c is going to be 2, 0 minus 2, 5, which is equal 2 minus 2 is going to be 0. 0 minus 5 is going to be negative 5. So here is the value of the vector c. So that means R of t is going to be equal to e to the vector 2t and 5 et minus 0, negative 5. You can type it like this, or you're going to combine these together. It's going to be the same thing. You can do that. It's going to be 2e to the 2t. C1 here is 0, and the second compound is 5e to the t minus 5. That's it for this example. So the last example, 15, is the integral from 0 to 13 dx over the cubic root of, is that the square? Yeah, the square is under the root. 1 minus 2x squared. So how are we going to find the integral for this one? First of all, I'm going to compare this one to the exponent and bring it up. So it's going to be negative. So this one is going to be the integral from 0 to 13. It's going to be 1 minus 2x to the power 2 over 3, and up is going to be negative 2 over 3 dx. Now we can't find the integral for this one. We're going to find it by substitution. So I'm going to let u equal 1 minus 2x. That means du is going to be negative 2 dx. Negative 2 dx divided by negative 2, because there is no negative sign here. So, and there is no 2 here. So I'm going to say this is by 2. And this one is by 2, by negative 2. Cancel this one with this one. That means dx is going to be du over negative 2. So what I'm going to do now, plug in everything here. That means this one is going to be the integral from 0 to 13. This part is going to be u to the power negative 2 over 3. And dx is going to be du over negative 2. Take the negative 2 out. That means this one is going to be the integral 1 over negative 1 over 2.
On the problem's actually 1 plus 2x.
Oh yeah, that's good. You should tell me from the beginning. Thank you.
You're welcome.
So here's a plus, here's a plus. So this one, 2, this one a plus, and this one is 1 over 2. Perfect. So this is 2. So now 1 over 2 out. This one is going to be u to the negative 2 over 3 du. That means this is going to be equal half. Let's do the integral for this one. You're going to add 1. So negative 2 over 3 add 1 is going to be negative, going to be positive 1/3. So u to the positive 1/3, because this one, you're gonna say 2/3 plus 1. So that means plus 3/3, and it's going to be 1/3. Over 1/3. And the border is from 0 to 13. That's mean flip this one, so it's going to be 3/2 u 1/3 and the border from 1 to 13. So this one is going to be equal. Now we're just gonna bring back the u, which is 1 plus 2x. So 3/2 u is 1 plus 2x, and the border is from 0 to 13. So this one is going to be 3/2. Let's plug in. If you plug in 13, also I forgot 1/3. Don't do the same mistakes. Because we have, let's check if it's working this calculator, because I think you have to use one Pro. So it's going to be, if you plug in 13 here, that means it's going to be 1 plus 2 times 13. 2 times 13, close the parentheses, to the power 1/3. Yes, that's good. It's going to be 3. 1 plus 2 times 13, 2 times 13 to the 1/3, so it's going to be 3. Minus, we're going to plug in the 0, so it's going to be 1 to the 1/3 is going to be 1. That's mean this one is going to be 3/2, and here is going to be 2, and the result is going to be 3. Wow. That's it. This is the whole thing. Is the border right from 0 to 13? Yes. That's it for this section. I know it's a long steps, especially when you go to the integrals, and we have to refresh our memory about some rules from Cal 2. So we can use it here, especially the derivative by parts and the way how to do the substitution. So that's it for this section. We just have to work on example. Which example? This one, the second part, example 12, because you're gonna get exactly the same thing. That's why I didn't solve it.